Hello, my name's Andrea Wingenroth. Henry, Zach, and I are going to be discussing how we went about performing a gauge R&R study on a study that we produced. We will be analyzing our findings in Minitab, so let's go ahead and get started. So a little introduction to the study. Our study consisted of 3 operators. This is me, Henry, and Zach. And we measured a green bean can using 3 different measuring devices. This included a ruler, a measuring tape, and calipers. 3 measurements were taken for each separate measuring device, and our end goal or objective was to see if there's any variance between operator measurements or between measurement devices themselves. This variation will be seen with the help of a gauge R&R study within Minitab statistical software. Obviously, this is a very simple study, and we hope it is an easy way to see how this type of study would be used in industry to see the variance in a process. So, the importance of measurement. It is important to be both precise and accurate when trying to meet specifications. So, accuracy has to deal with how close the measurements are to the actual true measurement, and precision has to do with how close each measurement is from one another. Here on the left, we can see if the target is in the center, then this would be considered both accurate and precise. If we see over here, this is precise, but it's not accurate because it's not hitting the center. And this is accurate because it's around the center, but it's not precise because all points are in different areas of the target. And this is neither accurate nor precise. It's not around the center and the points aren't together. So there's a lot of uncertainty in measuring, and a lot of it comes from human error. But one of this uncertainty is the varying increments in a measuring device. So the ruler we used has tick marks with the capability of reading 1/32 of an inch. And the measuring tape has tick marks that are 1/16 of an inch apart. Both allow for 1 degree of estimation. So for example, we can guess in between 2 tick marks that it's halfway or a quarter of the way, but that is an estimation or a guess. The caliper has a digital reading with increments of 1/100th of an inch. And because of this, and for the lack of human error, calipers are deemed more precise and accurate if calibrated than rulers and tape measures, just because what I said, there's less human involvement. So human error comes from like different perceptions between people. So there's variance from person to person. And this also comes from, the visual interpolation between tick marks. Everyone's going to read a little bit of a different value. So here are some important definitions and the setup of our gauge R&R. Repeatability is the variation in measurements taken by a single person and instrument, and reproducibility is the variation of different technicians' results when measuring the same object with the same measuring device. We want to see if it is possible to get repeated results of dimensions for varying operators and instruments. That's the purpose of our study. And results from a gauge R&R show if a process needs to be improved to lower this variation. In terms of data collection, we collected all of our measurements in random order, and Zach will go on to talk about this a little more in an upcoming slide. And our operators did not see each other's dimensions, so nothing was biased. And you can see here, this is how we set up the table. This is not how we input it in Minitab, but this is a simpler way of seeing it. You can see that we have the different measuring devices, and each device has 3 tests, and each operator does these 3 tests for each 3 measuring devices.
The gauge R&R study to obtain results of measurement variance. The data shows that the gauge R&R has three main groups of origin problems: the operator, the gauge, and the part variance. The results collected by the company can improve the whole process if needed to increase production while decreasing any mistakes. The analysis of variance compares the different means of groups to show if there's any statistical differences between the means. A certain limitation comes to using these statistical tools because, like in a one-way ANOVA, it can only be used for a single factor and a single dependent variable. The analysis of variance method, graphing. The R chart shows consistency between the operators. So if the values fall between a certain range, that shows on lines how close it is to the actual average that the operator had. The X bar by chart shows an evaluation, really showing the variation between the parts by collecting it for repeatability. Parts times the operator means that a chart shows the interaction between obviously a part and an operator. And we see the lines between operators to show if they measure up similarly in a similar fashion. And then response by operator and response by parts, it's a line connecting the average for each groups and between the measurements to see the variance between certain things. And we'll see this later on when we finish our mini tab. It's just a little explanation to get into it. So just a general process of how we obtain this data comes down to a couple of bullet points here. So one thing was it was in a random order decided mini tab using the gauge R&R study, and we'll see that in a little bit when we go to our procedure, to show the repeatability and not measure 3 times in a row, meaning that we didn't measure each thing each time, just 1, 2, 3 off the bat. We usually did 1, 2, 4, come back in a different order just to show if you could repeat the process and have the same results. Also, we don't really have like a formal training on how to use each of the equipment that we use. It was just more like a general understanding. Like it comes down to like reading a foot meter ruler and using 1/32 versus 1/16. Just kind of that similar idea that we've learned before. So there wasn't any professional training along with it, as well as each tool was zeroed before the measurement was taken, just to make sure, okay, we're starting at close there. But there was no calibration done on any tool, so we're not sure if the values that we got can really be based upon what it actually is, unless we actually went to and got it calibrated online. And the data was recorded by another member. I put this in here because sometimes when you are putting responses like that and you're working as a team, a number could be messed up, a number could be missing, or it could be too high, too low. Just to keep that in the back of your heads, we're talking about what kind of variations could go along in this study. So we get to main tab. What the first thing we're gonna do is open it up. We're gonna go to stat, quality, gauge study, and then create gauge R&R study worksheet. And that's what you're gonna get right here. Follow this little pathway. And when it comes into it, it's gonna actually get the sheet right here to create gauge R&R study. So when it comes into it, you have 3 main parts. You have number of parts down here, which is going to be like how many parts are going to be part of your study. What are you going to be studying? So if you need to do 10 parts, 10 trials, that's what it's going to stand for. Number of operators, how many people are we working on it? So you can label your operator 1, 2, 3. We put our names in there so we kind of knew, hey, you're going this one, this one. And then number of replicas, how many times is this trial going to be run? Are you measuring this can 3 times in a row? Are you going to be measuring this can 5 times? That's what that stands for. And the main tab continues. So when you press it, you'll get this right here. You'll have a run order when the trial should be run. The parts are changed. That means Andrew's going to start with part 3. This should do part 1, part 3. Sorry, part 2. And it's be changing. It has all the operators right here, the parts, the runtime, and then it's just the height that we recorded. So you can go to an Excel spreadsheet for each run of the trial that you have. You're going to get the measurements. You can also put them in here. Main tab is very helpful when explaining the run order and the operators in which we're running these tests. It's important to know that these have to be messed up and they have to be changed because that's the best way to get your variance to see what's going to happen in there. And so right here, I just have a little note. If you were doing something in tab right now to follow along with us, in C4, you probably want to put your lines right there. Continue on to main tasks. We want to see, let's get the charts. Let's see what we were talking about before, the X bar and the parts by operator. We're going to go to here. We're going to continue on. It's a stat, quality, gauge study, and gauge R&R. Follow this pathway right here to pull up a screen like this, which is gauge R&R study. Excuse me. Obviously, the parts are going to put your operators, and your measurement is going to be height in inches, which we recorded for your certain can or anything like in our case, or if you recorded it, obviously on a box or anything like that. And so finally, you end up with a chart like this where you can see variation between components for study variance. You can see our height by parts, our R chart, height by inches, just all these interactions that go along here. And we'll see in a second how you get to really explain all this through the results.
All right, so interpreting the results, what do the Minitab outputs tell us? So the first output from Minitab was the components of variance. So we see that 94.12% of the gauge R&R comes from the repeatability. And what this means is that a majority of the variation was caused from the individual operators repeatedly making the same measurements multiple times. 0% comes from the 0% of the variation comes from reproducibility, which means that there was no problem with the operators using a specific measuring device. So for example, there was no variation involved with using a ruler, and that there was no variation due to the flaws in the ruler. So the repeatability and the reproducibility make up the total gauge R&R, and the rest of the variation comes from the part-to-part aspect of the process. So 5.88% comes from part-to-part, which means that there was slight variance across the different measuring devices, and this could be contributed to maybe different levels of precision between the devices, and the part-to-part variation is caused by the process itself. So the gauge evaluation tells us a similar thing as the components of variance. Again, a majority of the variance comes from the repeatability, and no variance comes from the reproducibility. And the total gauge R&R makes up for a majority of the variation in the process. Again, there are slight contributions from the part-to-part aspect, which comes from the process itself. But in an important result from this output is the number of distinct categories. And we found that the number of distinct categories is equal to 1. What this means is that Minitab cannot distinguish between values that are in specification or out of specification. So Minitab just kind of reads our values all as one category. This means that improvements can be made to the process and the gauge analysis, and it's important to maximize this value if possible. Here is a graphical representation of the components of variance in the gauge evaluation. Again, majority of the variation comes from the gauge R&R. And the gauge R&R is composed of the repeatability and the reproducibility. Most of the gauge R&R comes from the repeatability, and there was slight variance coming from the part-to-part aspect. Another result is the R chart and the X chart. So what these charts tell us is that they show the stability of variance from each operator. So looking at the R chart, this top chart over here, these show the range of values of each operator. And there's a lower control limit and an upper control limit. Andrea and Henry had similar range values, and they were both within the control limits, which means that their measurements were stable and consistent, while Zach's range values were outside of the control limits, which means that he had more unstable variance. The X bar chart shows similar things, except it accounts for the mean values. As you can see, Andrea and Henry had means that were close to the mean center line, and Zach's means were a little bit more up and down and inconsistent. So again, operator Henry and Andrea had more stable variance, and operator Zach had a little bit more unstable variance. So the interaction plot shows how the operators and measuring devices interact. So how do the individual operators approach measuring? So Henry and Andrea had stable methods of measuring, and they were more consistent since their values were closer to the average center line, while Zach's values were a little bit more up and down, meaning that his method was a little bit more unstable and inconsistent than Andrea and Henry's. So improvements can be made to the analysis and the process. So some recommendations include increasing the number of trials, retraining each operator so that the variance will decrease, ensuring that the calipers are properly calibrated so that the variation would decrease and the precision would increase. Another recommendation is probably to mark on the cans specifically where to start and end the measurements, so that's it could decrease the variation since the operators have a clear understanding of what is being measured.
All right, so overall, we learned that a gauge R&R study is used to determine whether variation exists between operators' measurements or from measuring tool to measuring tool. In terms of our results, we concluded that operator Zach had a lot of variation between measurements and measurement devices, so he was less consistent. And operators Henry and Andrea were able to achieve more steady measurements. The difference in measuring device measurements saw the greatest variation. Many reasons mentioned in the recommendations as to why these results have occurred was mentioned by Henry. And that about concludes our term paper presentation. We learned a lot about gauge R&R studies throughout this process of writing the paper and coming up with this presentation, and we hope you enjoyed. So thank you.